Assalamualaikum everyone, my name is Fahad. I'm landing here at 6. In today's video, I'm going to tell you about the conductive immunity test. For this conductive immunity test, we're going to need the following setup, and you can see on your screen. I'm going to explain you one by one about each and every equipment and how we perform this test. First of all, I will show you about the instrument that is basically a signal generator. After that, we're gonna need an amplifier to amplify that signal to receive that specific strength of signal at our output. And after that, we have this front injection and front sensing probes. I will explain about them later. So for the conductive immunity test, we're gonna need the following setup. Firstly, we're gonna need a signal generator to produce that specific band of frequencies that ranges from 150 kilohertz to 80 megahertz as per standard. And we're gonna have to make sure that we receive a some specific level at our desired conducted line. So we're gonna in today's lab we're gonna perform this test level 1, that is basically making sure that we receive 100 dB microvolt on this strength of signal on this conducted lines on neutral and also on phase. And this is basically a signal generator with which we're gonna produce this signal that ranges from 9 kilohertz to 40 gigahertz. This is the frequency range of this signal generator. So our range will be easily covered by this, and we're gonna have to produce the modulated signal, AM modulated signal 1 kilohertz sine 80% modulation, to make sure we get 100 dB microvolt at the wire. We gonna need this power amplifier which ranges from 10 kilohertz to 100 megahertz, which covers our 150 kilohertz to 80 megahertz band. This is basically on standby mode. When we're gonna perform the test, we're gonna turn it on, and this is basically our device under that, which is same as we use for rotated immunity. This is oscilloscope, and now through this current injection probe, which ranges from 10 kilohertz to 400 megahertz, we're gonna insert or inject our 150 kilohertz to 80 megahertz band of frequencies, with making sure that on each level it gets 100 dB microvolt. And through this sensing probe, we're gonna sense the signal on this our EMI receiver. First, we have to make sure that the desired signal is receiving or is injected on this our wires. Firstly on line, then we're gonna check it on neutral, and we're gonna see it's working, whether the with the this emission this working is disturbed or not. If it is disturbed, it means that it is not working fine or working normal. It means that it is not immune to this test. So let's get back to that signal generator. Now we are back on this signal generator, for which we're gonna generate that frequency range 150 kilohertz to 80 megahertz. So firstly we're gonna have to set that sweep just like we did on in radiated immunity test. So we have to make sure that over that desired range 150 kilohertz to 80 megahertz we receive that 100 dB microvolt signal strength on this cable. So for that we will start by checking that at how much amplitude we get that 100 dB microvolt at our EMI receiver sensing through sensing probe. We have set this 150 kilohertz. Let's say I set minus 13 dB. First I turn on this RF signal and this amplifier. Now I will move to the spectrum analyzer, basically AMI receiver, to check whether that how much signal is receiving at 150 kilohertz. Now we are at the AMI receiver screen to check that what signal are we are receiving at 150 kilohertz. As you can see that we are receiving 87.38 dB microvolt, which is not enough because we need almost around 100 dB microvolt. As you can see that correction factors are also included in this because we are using sensing probes, so there are losses which are all catered here as a correction factor. So here we are getting the true value of it. So I'm gonna move back to the signal generator and I'm going to increase that signal value to get that 100 dB microvolt here. So here I am back on this signal generator interface. First I will turn off this amplifier, then RF output, and I will increase that amplitude as it is 13, so I will put this as 0 dBm, and I will turn on this RF output, this amplifier, and I will move to the spectrum screen. As you can see that now we are receiving almost 100 dB microvolt on our 150 kilohertz signal. So now I will move to the another step. I will show how to set this level strength on over all the frequency range. When this all is set, then we're gonna generate a sweep list just like we did on in Reddit mission, and I will just turn on the sweep and it will automatically be swept for our desired frequency range. That is, in this case it will be from 150 kilohertz to 80 megahertz signal level of 100 dB microvolt, including basically a test level strength 1, which is the test we are performing here on this oscilloscope. Now I am back on this spectrum signal generator screen. As you can see that now I will test it on 10 megahertz and with amplitude of -10 to see what I am getting at our spectrum analyzer, basically, which is EMI receiver. So I will just turn on this RF and then amplifier output and to check that what we are receiving on. As you can see that we are receiving almost at 10.108, so we have to just decrease the amplitude so that we get 100 dB microvolt on it. So I will move back to it and I will change the amplitude level on signal generator. So here I am back on this signal generator. I will first turn off this amplifier, RF output, and I will change the decrease the amplitude. Let's say minus 80 dBm. I will turn on this RF amplifier and move to this screen. As you can see that we are now almost getting 100 dB microvolt on it. Just like this, we're gonna set the amplitude level through signal generator on all the frequency range that start from 150 kilohertz to 80 megahertz. I will skip them. That for the video, I will make a sweep file just like I did for these two frequency points. I will make that for the rest of the frequency ranges. I will just put the sweep list into our signal generator. I will just turn it on. Now I am back on my signal generator screen on which I have stored my sweep list name as CS 150 kHz to 80 MHz. I will just select it from here. I will move to the sweep. I have selected sweep type as list. I will go to sweep. I will turn on the sweep. You can see both amplitude and RF. My amplifier is on. Now as you can see that my sweep is now start. It starts from 150 kilohertz and it will stop at 80 megahertz, covering all the frequency ranges. As you can see that with the frequency change there is a change in amplitude because at different level frequencies we get different level of amplitude to get that 100 dB microvolt at our current injection probe, so that to see that it is working fine or not. Now I will move to the equipment address, which is basically oscilloscope. As you can see that this switch is running, amplifier is on, and it is connected to this current injection probe. As you can see that oscilloscope is working fine. As you can see that sweep is still going. It is on around 3 megahertz with amplitude of -20 to get that 100 dB microvolt at this continuous probe. To check its conductive immunity, we are injecting our RF signal ranges from 150 kilohertz to 80 megahertz through this. As you can see that it is working fine. Sorry for the noise in the background. This is basically produced by amplifier because it has high power rating, so it needs fans to cool it down. We are checking it constantly that the working of this oscilloscope is fine or not, or any abnormality occurring here or not. As for now, the oscilloscope is working fine. This is just basically a demo video to demonstrate you about the conductive immunity test. We're gonna wait for it to complete its cycle, and meanwhile we will continuously observe this AUT, which is oscilloscope. We can also check it on parallel on sensing probe that we are also receiving that almost 100 dB microvolt point on this our desired in our desired frequency ranges. As you can see the shift in frequencies. And our equipment under test, which is oscilloscope, is also working fine with this. It means that it is immune, till now it is immune to our RF signal for test level 1, which is 100 dB microvolt. So we are now at 11 megahertz. So to make this video a little short, I will just pause it here and I will wait for it to complete its sweep cycle, and I will back to you. So we are back on the testing. The test is almost about to complete. As you can see that currently 964, 765 points is running. And the device under test is also working fine. As you can see that test is almost about to be complete. Only 81 points are remaining. The device is working fine. Press this RF output off button, amplifier off, sweep is now off. As you can see that the device under test, which was oscilloscope, is working fine. When we have applied a 150 to 80 megahertz signal strength of 100 dB microvolt on its line, it is working fine. Now we are going to check it on its neutral line also. and we're gonna perform the same procedure. We're gonna as you know that we have already set the sweep list, so we're gonna just recall the sweep for conducting immunity, and we're gonna perform the same process steps to that neutral line also. Now I have attached the current injection probe to the neutral line and also sensing probe to the neutral line. The device under test is on, turned on, and it's working fine. Now I will move to the signal generator. I will turn on the sweep, RF output on, and this amplifier start button. As you can see that now it is injecting that RF signal ranging from 150 kilohertz to 80 megahertz on this the neutral line of that device under that, which is oscilloscope. We will check its performance and whether it is affected by this or not. If not, then this device passes this immunity test for both lines. So it is safer to be used in an environment in which there is disruption of test level 1, which is 100 dB microvolt. So you can test any device as per its requirement, whether it need to be tested at test level 1 or 2 or 3 on any special requirement based on the end user. It varies, but the procedure that for you or we follow here is same. Now we will wait for a few minutes. To let that cycle complete, and we will be observing continuously the performance of this our AUP, whether it is affected or whether it will be affected by it or not. So I will pause this video here, and we will get back when the test is almost about to be